Namaste and once again welcome back to the online maths class. Last class you have learnt derivatives of functions in parametric forms and we have discussed some problems in exercise 5.6. Today we move on to the remaining part of exercise 5.6. Let me start with question number 7. Okay. So here the question is x equal to sin cube t divided by root cos 2t and y is equal to cos cube t divided by root of cos 2t. First we can find dx by dt. Here the function is given in quotient form, u by v format. So we have to apply the quotient rule. U by v the whole dash is equal to v u dash minus uv dash divided by v square. Okay. Denominator into derivative of numerator minus numerator into derivative of denominator divided by square of the denominator. So here denominator, that is root cos 2t into derivative of sin cube t, that is 3 sin square t into derivative of sin t is what? Cos t. Okay, sin cube t we treat it as x cube, so x cube derivative 3x square and instead of x the term is sin t, so we have to apply the chain rule, sin t derivative cos t. Clear? Then minus numerator into sin cube t into derivative of denominator, that is derivative of root cos 2t, root x derivative 1 by 2 root x, so 1 by 2 root cos 2t into derivative of cos 2t and it is minus sin 2t into 2 whole divided by square of the denominator, that is root cos 2t the whole square. Here 2 and 2 can cancel. This root cos 2t we can cross multiply, root cos 2t into root cos 2t, root changes cos 2t. This 3 I write first, 3 cos 2t. Then the remaining is sin square t into cos t. Here minus into minus plus, sin cube t sin 2t whole divided by this denominator root cos 2t, then one more term is there, root cos 2t the whole square, it becomes cos 2t. Okay, that is dx by dt is equal to 3 cos 2t sin square t cos t, then plus sin cube t sin 2t divided by root cos 2t into cos 2t. Okay, clear? Now dy by dt is equal to denominator, that is root cos 2t into derivative of numerator, that is 3 cos square t into derivative of cos t is minus sin t, then minus numerator, that is cos cube t into derivative of denominator 1 by 2 root cos 2t into cos 2t derivative minus sin 2t into 2 whole divided by denominator square, that is root cos 2t the whole square. Here also we can cancel this 2 and we can cross multiply as in the previous case, root cos 2t into root cos 2t, it becomes cos 2t, then 3 cos square t minus sin t, that minus we can write first. Okay, so it becomes minus 3 cos 2t cos square t sin t. Here minus into minus plus cos cube t into sin 2t whole divided by this one root cos 2t and one more term is there, root cos 2t the whole square, it is cos 2t. Okay, so here I substitute the values of dy by dt and dx by dt in the formula. Okay, we can cancel this denominator root cos 2t root cos 2t cos 2t cos 2t. Now minus 3 cos 2t cos square t sin t, then plus cos cube t. This sin 2t we can written as 2 sin t cos t. Using the formula we can rewrite like this, and the denominator 3 cos 2t sin square t cos t, then plus sin cube t into again sin 2t 2 sin t cos t. Here from the numerator And sin t cos t. Here also sin t cos t is there. We can take it common. Sin t into cos t. Within bracket, the remaining is minus 3 cos 2t. Here on cos t and sin t we take it out. The remaining is on cos t. Clear? Then in the next part, the number 2 is there. This sin t cos t we take it out. The rest is cos cube t. Okay. And in the denominator also we can take sin t cos t common. Sin t cos t into here 3 cos 2t and sin square t. From this one sin t we take it out. So sin t. Then plus here on 2 sin t cos t we take common. Remaining is sin cube t. This sin t cos t we can cancel. Okay. And the remaining is dy by dx is equal to minus 3 cos 2t cos t plus 2 cos cube t divided by 3 cos 2t sin t plus 2 sin cube t. Here I write this minus 3 and cos t first. Minus 3 cos t. And instead of this one cos 2t, I replace formula 2 cos square t minus 1. Cos 2t we have formula 2 cos square t minus 1. Then plus 2 cos cube t divided by, here also I write 3 and sin t first. 3 sin t into, then instead of this one cos 2t, we have another formula in terms of sin t, that is 1 minus 2 sin square t. Okay. Then plus 2 sin cube t. So for cos 2t, we have different formulas in terms of sin, cos and tan. Okay. So in the numerator we apply the formula in terms of cos theta, and in denominator we apply the formula in terms of sin theta. Okay. Now we can multiply minus 6 cos cube t, then plus 3 cos t plus 2 cos cube t. Here 3 sin t, then minus 6 sin cube t, then plus 2 sin cube t. So which is equal to minus 6 cos cube t plus 2 cos cube t, that is minus 4 cos cube t, then plus 3 cos t divided by, here the first term is 3 sin t minus 6 sin cube t plus 2 sin cube t. Minus 6 plus 2, that is minus 4. Minus 4 sin cube t. You can take one minus common. Minus of 4 cos cube t, this plus becomes minus. Minus 3 cos t whole divided by 3 sin t minus 4 sin cube t, which is equal to minus 4 cos cube t minus 3 cos t. Formula is at cos 3t. And denominator 3 sin t minus 4 sin cube t, that is sin 3t. Okay. Sin 3 theta and cos 3 theta, we have trigonometric formulas that we applied here. Okay. Cos by sin. Cos by sin is what? Cot. So it is minus cot 3t. That is the final answer is, that is dy by dx is equal to what? Minus cot 3t. Understood? Now we move on to the next question. X equal to a into cos t plus log tan t by 2 and y is equal to a sin t. First dx by dt is equal to a into cos t derivative minus sin t log tan t by 2. So it can be treated as log x. Log x derivative 1 by x. So we can write 1 by tan t by 2 into derivative of tan t by 2. Derivative of tan x is 6 square x. So 6 square t by 2 into again derivative of t by 2, and which is 1 by 2. Clear? I repeat, a is a constant, so a into cos t derivative minus sin t log tan t by 2 log x. This can be treated as log x. Log x derivative 1 by x. So 1 by, instead of x the term is tan t by 2. So first we write tan t by 2, then derivative of tan t by 2 is what? 6 square t by 2, and derivative of t by 2, that is 1 by 2. Now you can rearrange the terms. A into minus sin t then plus 1 by this tan t by 2, I rewrite like this, sin t by 2 divided by cos t by 2. Tan theta is sin theta by cos theta, so we can write like this, into sec is the reciprocal of cos, so we can write 1 by cos square t by 2 into 1 by 2. Understood? Now on cos t by 2, here on cos t by 2 we can cancel, that is a into minus sin t then plus 1 by this 2, I write first, 2 sin t by 2 cos t by 2, which is equal to a into minus sin t plus 1 by 2 sin t by 2 cos t by 2. Again we apply the formula sin theta, sin t. Sin t is equal to 2 sin t by 2 cos t by 2. So you can write, instead of this one 2 sin t by 2 cos t by 2, we can write what? Sin t. Now we can cross multiply this one, a into minus sin square t plus 1 divided by sin t, and which is equal to a into this, we can rewrite, that is 1 minus sin square t divided by sin t, minus sin square t plus 1, I write the positive term first, 1 minus sin square t divided by sin t, and again we have formula 1 minus sin square theta is cos square theta, so a into cos square t divided by sin t. So dx by dt is equal to what? A cos square t divided by sin t. Understood? Now take the second part, y is equal to a sin t, and dy by dt is equal to a into derivative of sin t is what? Cos t. Now dy by dx is equal to dy by dt divided by dx by dt, which is equal to dy by dt is a cos t, so a cos t divided by, and dx by dt is a cos square t divided by sin t. This a and a cancel, on cos t cancel, this sin t come to the numerator, and taking reciprocal, that is sin t divided by here on cos t, and which is equal to tan t. So the derivative dy by dx is equal to what? Tan t. Understood? Now we move on to the next question. X equal to a sec theta and y is equal to b tan theta. So first dx by d theta, which is equal to a into derivative of sec theta tan theta. We have direct formula, so we applied here. And y is equal to b tan theta, that is dy by d theta is equal to b into tan theta derivative sec square theta. Okay, so direct formula, so I write here. Okay, now dy by dx is equal to dy by d theta divided by dx by d theta, and which is equal to b sec square theta divided by a sec theta tan theta. Sec square theta on sec theta we can cancel, and the remaining is b sec theta divided by a tan theta. And again we can simplify, b by a I take separately, sec theta I can written as 1 by cos theta, and tan theta is sin theta by cos theta, so I can cancel this cos theta, and the remaining is b by a into 1 by sin theta. 1 by sin theta is reciprocal of sin theta, and it is cosec theta, so the final answer is b by a cosec theta. That means dy by dx is equal to b by a cosec theta. Clear? Now we move on to question number 10, and it is x equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. So first we can take the first one, dx by d theta is equal to a into cos theta derivative minus sin theta, then plus here theta into sin theta. So we have to apply the product rule. It's in UV form, so So we have to apply the product rule. First function theta into derivative of sin theta is cos theta, then sin theta into derivative of theta is 1. Understood? Theta first function, sin theta second function. So theta into sin theta derivative cos theta, and second function sin theta into derivative of theta is 1. Here on minus sin theta plus sin theta we can cancel. So a into theta cos theta, that is a theta cos theta, that is dx by d theta. Clear? Now dy by d theta is equal to a into sin theta derivative cos theta. Here also product rule, theta into cos theta. So first function theta into cos theta derivative minus sin theta, then plus cos theta into derivative of theta is 1. Okay, so a into cos theta minus into minus plus theta sin theta minus into plus minus cos theta. Minus cos theta plus cos theta cancel. A into theta sin theta, that is a theta sin theta. Now we can divide dy by dx is equal to dy by d theta divided by dx by d theta, which is equal to dy by d theta is a theta sin theta. So a theta sin theta divided by dx by d theta is a theta cos theta. Here a theta cancel. Sin theta by cos theta, and sin theta by cos theta is tan theta. Therefore dy by dx is what? Tan theta. Understood? Now we move on to the last question in this exercise, and it is given x is equal to root of a raised to sin inverse t and y is equal to root of a raised to cos inverse t. We have to prove dy by dx is equal to minus y by x. Okay. So first dx by dt is equal to, here root x derivative 1 by 2 root x. Instead of x, the term is a raised to sin inverse t. A raised to x formula, a raised to x into log a. So a raised to sin inverse t into log a. But instead of x, the term is sin inverse t. So derivative of sin inverse t, and it is 1 by root of 1 minus t square. I repeat, first we take it as root x. So this a raised to sin inverse t, we consider it as x. So root x derivative 1 by 2 root x. So I write like this, 1 by 2 root of a raised to sin inverse t. And instead of x, the term is what? A raised to sin inverse t. So we have to apply the chain rule. That's why I write a raised to sin inverse t into log a. That means derivative of a raised to x is what? A raised to x into log a. But here the problem is it is not x. Instead of x, it is sin inverse t. So again we have to apply the chain rule. Sin inverse t derivative 1 by root of 1 minus t square. Understood? Now we can find dy by dt. Here also we can follow the same method. 1 by 2 root of a raised to cos inverse t into a raised to cos inverse t log a into derivative of cos inverse t. It is minus 1 by root of 1 minus t square. Clear? Now we can replace the values. Dy by dx is equal to dy by dt, this one, that is 1 by 2 root of a raised to cos inverse t, a raised to cos inverse t log a, and minus 1 by root of 1 minus t square whole divided by the first term, that is 1 by 2 root of a raised to sin inverse t, then a raised to sin inverse t log a into 1 by root of 1 minus t square. Here this 1 by root of 1 minus t square we can cancel. Log a cancel. This 2 and 2 get cancelled. Clear? Now the remaining terms are dy by dx is equal to a raised to cos inverse t divided by root of a raised to cos inverse t by, here a raised to sin inverse t divided by root of a raised to sin inverse t. and here there is a minus sign that we can write here. Okay, and we know x can be written as x is equal to root x into root x. Root x into root x, it becomes what? X. Here the situation is, it is given in the form x by root x. So what happened? One root x get cancelled and the remaining is what? Root x. So here a raised to cos inverse t by root of a raised to cos inverse t. Here we can cancel these two terms. The root or the radical sign comes on the numerator. Okay, x by root x is equal to what? Root x. X by root x is equal to root x. So we can write minus root of a raised to cos inverse t divided by, here also these two cancel, root of a raised to sin inverse t. That is minus root of a raised to cos inverse t is what? Y. So minus y by, and root of a raised to sin inverse t is what? X. So it becomes minus y by x. That is dy by dx is equal to minus y by x. Understood? So this finishes the topic derivatives of functions in parametric forms. I think you understood the concept. If you have any doubt, you can ask me in the comment section. Thanks for watching. Thank you.